Hoy, aunque lo comentan en clase, porque casi todos sois de mecánica, pero hay gente que es de cuarto y otros que no son de mecánica. Esta semana, vienen ya creo que es el cuarto año, Paulo Branco y João Fernandes. Paulo Branco y João Fernandes, yo los conocí en el año 2016. Me fui de estancia a Portugal a un laboratorio hidráulico. Es decir, cuando llegué íbamos a analizar bombas trabajando como turbinas y la bomba que tenía que trabajar como turbina no tenía generador y me dijeron que me buscase la vida a buscar al profesor que lo tenía, que estaba de vacaciones y volvía el 1 de septiembre. Yo no pensaba que lo que fui a buscarlo a la puerta de un aula para que me dejase o devolviese al laboratorio de ingeniería hidráulica el generador, pues se ha convertido en 7 años de sinergias trabajando la hidráulica con el área de energía eléctrica y electromecánica. ¿Vale? Entonces, este año cuando vinieron, generalmente dan una charla en el grupo de tercero de ingeniería fluidomecánica relacionada, hablando de bombas trabajando como turbina en el aspecto electrónico y eléctrico, pues coincidiendo que estaba el programa de la Semana de la Ciencia, pensamos en desarrollar, junto con Vicente Díez, una conferencia en la cual os hablase la importancia de las sinergias en las profesiones, porque siempre en clase os lo digo, que el ingeniero mecánico no es solamente el engranaje, hay más cosas. Y a ese engranaje siempre tiene que ir acoplado a algo. Él, junto con João, lo que han preparado es una presentación en la cual os van a mostrar cómo, a través de trabajos eléctricos que ellos han estado desarrollando en clase, con alumnos de tesis de máster y alumnos de doctorado, en su área del Departamento de Ingeniería Eléctrica y en su laboratorio de Ingeniería Eléctrica, se necesitan también conceptos de la ingeniería mecánica. ¿Vale? Pues nada, Paulo es profesor, lo que aquí en España es el profesor titular, yo es lo que aquí en España es profesor contratado, doctor, los dos trabajan en el Departamento de Ingeniería Eléctrica. Primero Paulo os hablará de esos trabajos, esas sinergias entre la ingeniería mecánica y la ingeniería eléctrica, y João también después os hablará del proyecto Viena, que también tienen y colaboran. ¿Vale?
Okay. Okay. Let's begin talk a little bit slowly, and I can summarize my life, why electromechanical, and so on and so on. I came with my engineering degree and master degree from the Rio de Janeiro. Yes, long ago, 30 years. Were you not here? You were swimming in some place. I came from the control systems in engineering, electronic engineering. After I started in electrical engineering master degree in the control of electric motors, also in the Rio de Janeiro. And at that time, I came to Portugal because the things were not so bad at that time. High crisis, an inflation about 3-4% a day, not a year, my friend. And in Portugal, I had my PhD also in the learning systems applied to electrical drives. So machine learning, it is a very, very old subject. It was called Maria, but now it's called Mary, you know, like a buzzword. I work with fuzzy induction machines and so on and so on. So we are now in a mechanical research center. Why mechanical? Because I knew some people and they work in mechatronics. Okay, so I like to join the things. Today you cannot separate the things because the things are in a system. Okay, you cannot separate, for example, the motor or generator with the problems in the materials. The materials are the key for the new technologies, my friends. New materials. You'll have a lot of new materials, new devices, new systems. So you begin with a thing that is internal of your body and you start to see out of. So I like this. I like to make some similarities and so on, okay? So it's not here, but we are now working in superconductivity for the new machines again, cables, transmission, and I think that in the next 10 years you will have almost superconductivity in the normal temperature. You know what is superconductivity was? Okay. Have you seen the things in the YouTube levitate and so on? It is all fake. And one day I will show to you, because it remembers that is miracle. No, it is not. They hide things. Why? So let's begin a little bit. Professor Modeste told me to prepare something. That did not give me the subject. So I thought about to join the two, and I gave him the mechanical and electrical engineering, that swinging together. It's all a title to make one other thing. So this is me, and this is my colleague. It is there. He was my PhD student, and now he will be my successor. I'm preparing him, of course, because I know I trust him, and I know how to do the things. If I'm going to die, no problem. So, guys, I discovered this is not doing by me, but I like the new term that I imagined today. Sometimes you see electrification to decarbonization. I hate buzzwords. I hate buzzwords. So, because buzzwords is only a name. But I think that it is better to put here electromechanization to decarbonization. Not electrification, not mechanization, but electromechanization. What is decarbonization? Don't breathe. If not, you have CO2 here. Don't heat. Don't go to the bathroom. Okay, you are producing CO2. You know, methane. Methane is the gas that you produce in the banho. Yes, it is methane, my friend. Put a fire, so on. Boom. So this picture for me, it was very good because it divides in 3 parts. 1, 2, 3, 4 parts. You have the renewable energy. You have the energy that can come from different places, of course. You have the energy carriers, the hydrogen and so on. And you have, of course, the transportation. The problem today for the decarbonization, if you want, it is transportation. Forget one thing, my friend. Electric vehicles, there are no space for more vehicles in our streets. If you go to Valencia, not here, you don't have any embotellment here. But if you go to Valencia, you will see. If you replace all vehicles, or if you put more electric vehicles with combustion engine, you don't have more space to have vehicles, guys. You don't have. Why? Let me see. First, for you, desenho e engenharia de veículos. This is your place, okay? You have materials, and you have the integration of the systems. This is where you have to do. Mainly today, the new ships, the aviation, and mainly the rails. The rail, it is the trains, okay? Second, desenho e fabricação de máquinas e protótipos. It is almost here, okay? You see a lot of prototypes. So you will work with electrotechnical, mechanical, management, and there are some words that you have to put in your head to understand the language between all engineers, okay? Second, materiais poliméricos e compostos. This is related with the vessels where the guys are storing different fuels and hydrogen. Hydrogen, it is a name, it is not a new word, guys. It is not. I have worked with fuel cells 15 years ago, PEM for cells. Why don't you see a lot of fuel cells in vehicles? Very simple. You know, a fuel cell has a polymer, and the polymer, it dries with the operation. So you start to have different regions in the polymer that are dry and you do not have any electrochemical reaction. So after 1 year or 2 years, depending on the vehicle, how it is managed, you have to change all polymers. It is Nafion. You know Nafion? No? You know the frigidaire. Como é que é frigideira? Frigidaire? No? Ixi. Where you put the huevos. And you cannot catch the huevo. They use Nafion to that. So it is the polymer that you use. You know. So you don't have any fuel cells in the vehicles today because of this, and also where to put the hydrogen. Where? And they are trying to see the materials to use in the certain vessels that are not heavy, and also they can manage the pressure of the hydrogen inside. Now I have seen that Airbus and the other companies, they are trying to do this, to incorporate inside the airplanes. Yeah. You sleep 3 p.m. No? Or 3 a.m. So there are a lot of things, and again, these three are connected. The last one, it is about the system level. Okay, the engineer de projetos, as you told, it is how to manage the different energies that you are available. So you need solar, you need wind, and you have to manage these things to consume or to have a low energy consumption and pay less money in your bill. So what is less bill? What is to pay less? If you pay 100 euros a month for the energy, and if I tell to you that it will be reduced in 10%, you give a shit. So the idea is that, so guys, do not trust Iberdrola in this and so on, that you put in your house, PV systems and so on. Because what you have the energy to waste, it is your, como é que é frigorífico? It is your fridge and in your heaters. So you don't turn off the fridges. If not, you have to put a hole in the, as 200 years ago. 200 years ago, they put a hole in the floor and they put the food because it was more cold. Okay, and you don't want to have to not be warm like that. So there are no place, my friend, to reduce the energy more. In our houses, by wood, como é que é? Fogão. Forno. Dá para perceber, ouvem? É em português, espanhol. Okay. So, one of the first persons that was an electrical engineer and at the same time a mechanical engineer was Nikola Tesla. Nikola Tesla was Serbian. Okay? It was a surprise for me this morning. I have discovered this in this morning. But it is, like I call, it is synchronicity. So it was electrical and mechanical engineering, and it came here in a very good time. So this was a guy without computers, without digital, nothing, only the head. And it is made the first patent about the machine or the motor that you have in your house, in your fridge, in your microwave, in your dishwater, in your clothes washing, and you have a lot of things. So imagine a guy in 1988 that had an idea without computer, without nothing. Imagine, guys. Okay, this came from his head. okay? I like this. This was the first machine that is made, and I have discovered one thing that is, let me put here, a video in the United States that they had constructed here. It is a movie. There are no, we have sound here. They have constructed the exact machine that this has made. Guys, you have here a field like that, a field, pulsating field like that, and you construct a rotating magnetic field. I don't know if you have a notion of a magnetic field that is rotating, and it is like that. Two-phase machine, in that time, the first AC machine that they have constructed. So imagine it, to have this idea from nothing, okay? This is from the museum, the Tesla Museum in the United States. Okay. So, let me tell you one thing. The machine that you have, they have the same field principles, but the materials again changed. Do you have new materials for the ferromagnetic? You have new materials for the coils and so on. So, these new materials allowed us to shrink the machines. And shrink the machines is very good. This is the objective for the aircraft or the electric aircraft airplanes. Okay. So guys, again, materials, production to decrease the price, additive manufacturing, you know this name, okay? So you have all things in the same product. Okay. You can put questions if you want, huh? Don't be shy. So, electromechanical tractions. So, electric vehicles again. Guys, the first electric vehicles that appeared were made using lead-acid batteries. It was in it was Ford. The first electric vehicles, guys, no, nothing new, okay? But the question is, I'm sorry, I have to appear in the video. It's getting crazy because I'm going to side and side. Why they give up about these electric vehicles? Why? Because in that time they discovered in Texas that when you do a hole, there were a lot of petroleum. So the petroleum in that time was like water in Texas. So if the petroleum is very cheap, bye-bye with these initial electric vehicles. It was the Ford T, where you had a DC machine and a lot of batteries below the people. So, in this, this was the first electrical car to speed racing. Imagine, this has been constructed, this is the original photo, and this is a prototype that they have constructed. I will show to you. And they reached 1,150, okay? That speed that you do not use, of course. We only have 140 kilometers per hour, okay? Because the girl likes too much to go with you. So I have a video, a small video here, that you can see a racing. You see an old vehicle, a classic vehicle, and this using again batteries and DC machines. Okay, of course. What is the problem with this vehicle? The problem is the weight. Okay, the problem is the weight. So again, let me do this. So these ideas are not new. No, not new. Not. Let me put here. This was the first train. I like this photo because it was made in the first international or in Berlin exhibition in this time, and it was a new, and we have a lot of ladies and gentlemen playing. It's like our children today, when my children, of course, I don't know if you have children, but in Christmas we take the child to go to, and we also would like to go, but we cannot because the people will tell like that. You know, we are child also. So this is made for the metro in English in England. This is the original one. Okay. More. Let me show you here. Now let's talk about a little bit. I want to put here about the new electrical trains that you have today. I don't know if you study bogies. This is called bogie. Bogie is put below the train. And you have a lot of work here, guys. Alstom, Bombardier, and other ones. What you have here? You have here the electric machines. And you also have here gearbox. And also, this part is very important. Okay, let's put in the mechanical terms. You have to do the project of the piece. And if your project is not well done or the material has some parts that are weak, bye-bye. You will have vibrations. Vibration pass through the gearbox. The gearbox, the efficiency decreases. It can break the teeth, and you know. Okay, you have to select a material with a high Young modulus for that, and the poor electric motor feels everything in the axis. So any vibration here will pass to the machine. I have seen one time in Portugal, the interior part of the electric machine has touched the stato di auto part. They have make a certain slip. Okay. So this is the, this is the heart and the lever and the lever and so on. So this is very complicated, okay? Mainly, for example, the slip between this part and the railway. The slip is very, very, very important. More. This is also a small video that I take from India. India, the people. It is not in Hindi, okay? You have a lot of Indian people that are put this in the YouTube, and there are some companies, and you can see here they have very good things. They have the music, awful. It is a street music. It's like that, but you can see. This is the connection between the wheel and the motor, and we know that today this is very important. Of course, this is a basic gearbox, okay? The most simple. The gearbox today, you have hydraulic and so on. You have gearbox that have 80 or 90% in efficiency, okay? So we are not mechanical or electrical dumbbell engineers, okay? More. Tell me. Fala, Viking. I told him that he's remembered me a Viking person, but you are Spanish, you see. I'm sorry. I'm sorry, guy. I like this guy. So, the AGV, this is done by Alstom, and Alstom they are projecting these new unities, this bogie. I don't know if it's Spanish. It is called bogie. How you spell this in Spanish? Bogie? Bogie. Yeah. In Spanish is called like that. It is I'm not sure, but in English or in French it is bogie. I don't know. Again, you have the electric machine here. Of course, I'm putting electric machine because I work on them, but I cannot see the electric motor separated for the other things. That's why I like to mixture the things, the electrical and mechanical. And you have a lot of headaches, my friends. Don't sleep. It is a guy there. It's like You see, it is always that guy that looks far behind and only sees the wall, and you don't have anything there. It is the same. So, they start to using electric machines with permanent magnets. Have you seen that today the permanent magnets are like a miracle? All things have permanent magnets. In the electric machines, in the aerogenerators, in our fridge, and so on and so on. There are a problem with permanent magnets, my friends. They are almost produced by the Chinese. And the price is increasing, yes. And General Electric, I have seen, they have a project, and also Siemens have a project to construct electrical motors or electrical generators not using permanent magnets. Desculpa. Yes. The Siemens and also General Electric, or this was General Electric and General Motors. They have a unit. Siemens have constructed a new unit in Germany, all dedicated to the electric machines, but without permanent magnets. They want to use new materials, new ferromagnetic material as vanadium cobalt that is working. For example, so the magnetic saturation is around 1.5 Tesla, more or less. You have magnetic circuits in mechanics. So the normal iron is 1.5 in saturation. This can go to 2 or more Tesla. Okay, this is a material that is not here, I think, but it is used in the military aircraft. Okay, so they are trying to liberate the permanent magnets. Okay, so be careful with that. And you have a niche. Let me only to, I know that I speak too much. Sometimes I go to subject. Today, I have seen that there are a lot of companies that want to contract electromechanical engineering to project the new machines. A lot of guys, a lot of. Okay? I'm not putting the sauces to my plate, but you have a lot of. I have seen that. Machine learning, there is a lot of. Machine learning is not a good bet. Huh? Go to me. So this was the first submarine that they have constructed. Electrical also. It is electrical also. Why you need electrical submarines? Because of the noise. Noise, guys. You see? This was the first model. It was a DC motor. So you see, 3.5 kilowatts is a machine that you have in your house. This machine at that time was this width. Again, materials. Better materials. You can put more power in less space. Okay? More. This is only for show you that they have a lot of market now to the ships, of course. And again, you have a lot of things here. And I like that. This is not the Novska or that boat or ship, that the Russian ship that had sunk. Está a perceber? Não? Ship, Moscow, Putin, fundeu? Entendeu? Pronto. So, this is a Royal, it is a destroyer that uses a huge induction machine. Why they are replacing this? Because again, the noise and the energy efficiency. They use here, some parts are fuel cells, some parts are batteries. Why they use fuel cells in the Navy? Because they catch the water sea, make the connection or make the electrochemical reaction and produces hydrogen. So it is so good to go in a boat and you have the fuel in your side. That's why you see this. Also the submarines, they do that. So a submarine can stay below 1 month, 3 months, and so on and so on. Okay? Putin knows that. Yes? They have a lot of good projects, guys. They don't have high technology, but they are very smart, very, very smart. So, I like this because this has been followed by Airbus. Is the following, guys. I think that you have studied the compressors here, okay? Majority of you, I have these thermal motors or something like that. Today, the generator that produces the electricity for your airplane is located here inside of your turbine. But they want to put here inside and located and glued to the axis and take advantage of your speed and power that you have here. There is a small space here. They are working on this in the next A380. Okay, so you have a lot of things to study and go to Toulouse. Toulouse, guy. Toulouse. You have a lot of things there. So, again, we need new ferromagnet materials. We need a lot of metallurgical guys because these materials has to support or high temperatures or high centrifugal forces. Okay, and this is very pursued. New permanent magnets, yes. We don't like Chinese people. Only Chinese that has the store side. No? Estás a perceber, não estás? Chinesão. Chinese, I call it chinesão. It is a great Chinese supermarket, something like that. Okay, we are finishing this part. Wind generators again. Wind generators, you have also composites. The secret in all aerogenerators are the composite guys. They have projected these como é que eles chamam? Como é que chamas o? Hã? Nacelle also this part here. They have projected this based on experience that you have from your turbines in the airplanes. So the secret is how to put the shape of these parts here and the composite here. They have to be strong, but they have to be a little bit elastic without things. Of course, you have again all this part here, again the gearbox here, the machine and so on. So you see a lot of things here. You have here in Spanish the companies that you have. This is the generator again, of course. It is too much heavy. Why it is too much heavy? Why don't you have, I will put a question. Let me see. I'd like to put a question, but the guys there, not the guys here. Oh, I like the guys here. I love far away and far away. Let me see, in the WhatsApp or in the Facebook, you have a lot of information and girls and so on and so on and so on. Yeah? So let me see, why don't you see a motor or electric machine made by crystal or made by acrylic? Huh? Why don't you see that? You consult the Facebook and in the iPhone. Why don't you see? You see why? Because you need to concentrate energy and you have to use ferromagnet materials to concentrate the energy. If you don't have, if you put acrylic, imagine a car, electric car, with acrylic motor, huh? Very fashion. Girls will like. Oh, girls, cars, you know, girls and cars, cars and girls. That's why I usually told that the electrical cars, it's like, father, buy an electrical car for me because I do not want to be a virgin. Yeah. You buy an electrical car and you go in to go to the girls. Girl, I have an electrical car. I'm sustainable in energy. I'm in energy transition. It's like that. Yes, you know that it's like that. The same with the iPhones. The same with the other things. Because in my time, we used radio and the radio will go out from the car, and all people would look to use this radio in the shopping and so on to show you that your radio is Panasonic or have letters in green. It is the same, my friend. It is the same. So if you have a colleague with a small electrical car, it is to go to the hunt. Yes, it is. Sorry, we are like that. We are like animals, but we are animals. I was like that, and I have a daughter more or less like you. So I know what is the zoo out of my house. I know. Yes. But the guys only have courage when they take some beers. Okay. This is the almost the new or the last example. It is the Higiénico paper that is done in Renova. It is a fabric, and they have project this machine that puts the wood there and smashes the wood to produce the paper. Okay, so I have worked there because of the energy consumptions again in the electric machines, guys. I'm not putting again or pulling for my side about electric machines, but the electric machines are in a company are 300 or more. I have worked also with old people. It was Corte Inglês in Lisbon. I was there. It's like a small village, guys. I was looking. They have a swimming pool like that here, a lot of water. It used to operate alone. I was admired. It was 300 electric machines there to the pumps and so on and so on. 2 teams for the maintenance, one in the day and the other in the night. What we discovered about the team in the night? Oh, sometimes there were peaks of energy in the night, and people did not know. Parties. Yeah. And people knew about that, you see. Of course, they are alone, parties, and when you connect the air conditioner in the Corte Inglês, there is one thing that is very bad. Because you turn on the air conditioner, and the air conditioner, it is turned on in all places. So you are wasting energy and so on and so on and so on. And we discovered that, okay? But I don't know what happened. So, to finish now, who has a Tesla car here? No? Poor guys. Eu também não tenho. I have also not. I don't have. Guys, you know, today, to have a Tesla, it is chic, okay? You have 500 kilos of batteries in this car, 500 in all electrical cars. So, what is interesting in this car is that they use to put here the electric machines and the electronics in the same vessel. So there was a project for this vessel and hydraulic oil. The hydraulic oil have a pump here. The oil passes here, passes also through the electronics and the machine to make one thing that is very important, thermal management. Thermal management, for the mechanical guys, it is an area that is critical. An example. You are a tiger. No, it's a tiger or it is a cheetah. You know cheetah? Cheetah can run until a point where it feels that the temperature is so high that she has to stop. If not, die. So this is an example that I gave to you, to my students. So thermal management, it is a critical one in electrical vehicles. It depends if it is like that or if it is a taxi or a truck, for example. Because you can catch more, but you have to spread the heat. So new fluids, pumps, the pump guy, professor, You see this, the two. And we have persons in the United States that have bought a lot of electrical cars to smash, to cut the car, yes. They have bought that to see what was inside. Okay, so they have cut, and you see the power electronics making this design. This design is to take advantage of the oil here and also the volume and so on. Okay, more. This is a machine that uses copper. They do not use aluminum here. They use copper because it is better. It has a high conductivity. This was the best idea that the people from the Elon Musk. It is Elon Musk, no? Yeah. Don't trust Elon Musk. It's only market sometimes. Okay. Now I will pass to a small vehicle that we are trying to project. This my colleague will tell you. It is a project that you see that there is mechanical guys, electrical guys, physical guys. Okay. So, thank you. I will pass to him. The show is turned off.
Okay, this is a very short presentation about a project that we have in Lisbon. It's a project made by students for the students. Okay. Before we start, let me say just one thing about me, is that when I was finishing my master's degree, I started a startup company, and the idea was to design a new wave generator. Okay. And my team was made of myself, from the electrical part, and a mechanical engineer. Okay, so me and my colleague worked together to try to build a generator, an electric generator for wave energy. It lasts like 5 years, and just for you to see, there is a synergy always between electrical and mechanical. Even in Portugal, sometimes when a company wants to hire some engineer, they say electrical or mechanical engineer. Okay, so as you can see, electrical and mechanical, they always work together. Okay, and this project here is just for you to understand how they can link together. This is an electric car, a Fiat car that it had an internal combustion engine. It was removed and it was transformed to an electric car. Okay, and this was done by students. Okay, it's not a research project, it's like a pedagogical project. It is a project that was for the students, even electrical and mechanical departments, to understand the electric cars. Here, okay, I think the size of the window is a little bit off, but it's a project made by students for students, and just for you to see, this is our team right now at the moment. Okay? In the end, you will have a picture with all the people that pass through this team. So we have here the electric team. Right now it's a little bit huge because we are changing the motors, the inverters, and the batteries. We have here decision and control team. Okay? In the top, Professor Paulo, as you knew today, myself, a PhD student, master students, okay? 2 professors from the decision and control area, some students, and mechanical department. Right now, the mechanical department is not so large as the other part because we are still finishing some parts for the critical parts, that is the traction. Okay? After the traction, we will need a lot of people from the mechanical. We are, as electrical engineers, focused on the electrical powertrain, batteries, inverters, and motors. Here, these people are looking for autonomous driving. Yes, this car should be autonomous. Okay, so it's electric and autonomous. Steering control and powertrain also. And right now, the mechanical department is working with sensor management. Okay, because if you only use GPS signals, you have an error of 3 meters. So that can mean that it can be inside the road or outside the road. So having a GPS, it's not enough. So the vehicle itself, you have on the back here an electric motor, okay? 20 horsepower coupled to a differential gearbox. What do we want? We want to get the maximum efficiency possible. Do you know the typical efficiency of the internal combustion engines? 30, okay? And about this, so the gearbox plus the electric motor, what do you think is the efficiency? 60? No, higher. Okay, maybe 80, around 80, okay? If you say the electric motor has like 95% of efficiency, okay? And then you have the gearbox, it's lower. But the overall, it can be around 80% of efficiency. That's why we think that electric vehicles should be the future, should be. We don't know if we still have the technology to have a full-scale electric cars because the batteries are the main problem, okay? We also need people from mechanics to do the vehicle dynamics, okay? We want to reduce as much the drag coefficients and the weight of the cars using new materials, new composites. This is your field, okay? Another part, we have the batteries. Here it's just a short amount of batteries to have like an autonomy of 1 hour maximum, okay? The inverter to control the electric motor. And in here, again, so reduce the weight of the vehicle, reduce the drag coefficients, but if you go fast, you cannot put your car flying, okay? You need to bring it down. The downforce, it should be there. So this part is yours. This is the mechanical part, okay? There was a race that the race car was so fast that the vehicle went like this. I think you should know something like that, okay? So new materials, more. This part, so we have 2 sets of batteries. Batteries for the traction in the back of the car, the ones that I show you. And also we have another set of batteries for auxiliary systems. Why? Because usually these ones, we have a big voltage, okay? And if some people touch there, they feel the electricity, okay? They may be dangerous. With the small batteries, that's fine if someone touches the batteries. Okay, it's a small voltage, you touch, nothing happens. So we have the back batteries for the traction isolated, and the front batteries here on the hood, just to all the auxiliary systems that you need inside the car. Okay, we have those 2 sets of batteries. This part here is the controller of the steering wheel. Okay, so we have a controller for the motor that put my car moving. We have a controller for the steering wheel, put the car turning. And let's go to there is another one that is the communication and the sensoring, okay? This is the brain of the car. We are using a Raspberry Pi. Do you use Raspberry Pis? Okay. We are using Raspberry Pis, several ones, okay? One for the batteries, one for the motors, one for communication of everything. And they should receive a lot of signals, like this is inertial, magnetic, and gravitational sensors, so they catch the attitude of the car, if the car is like this, or like this, or like this, or like this, if it's moving, the inertia. GPS sensors, we will install also, of course, cameras, because we want to be autonomous, and you have to merge the information of this sensor, the information of this sensor, the information of the camera, to try to know where is your car. Because right now, only with this and with this, we have an error of around 2 meters. Okay, so I can be here, or I can be here with my car. It's not enough. Okay, so you need a camera also. And there is a master thesis in the mechanical department that is mixing all this information together to try to have a very good prediction where the car is. Okay? And of course, in the end, we have the steering control and the traction control. Okay? So as you can see, communications, electric engineers, we need mechanical engineers, decision and control engineers. It's a multidisciplinary team, and this is what you will find in a company, of course. Okay, so and you need to talk with people from the other areas. Let's go to the fun part, is the videos. Okay, this video here, we were testing the steering. It was controlled by phone. Okay? So the first thing that we do is we turn the steering wheel for one side and then to the other side. He catches the maximum angles and then he knows exactly where it goes. Okay, you can see here, he's turning the wheel in one side, and then in the end we say, okay, put the steering wheel in this position, and he's going there. Okay? So, steering control. Next, we have the traction control, the motor. We have a computer where we say, put the wheels at this speed. Okay, we were testing inside the laboratory first. So now the wheels are turning to the front. This was from the computer to the Raspberry Pi to the controller of the motor to the motor itself. Okay? So now it should be going backwards. So we have the steering done, the power, the traction power motor done, and the batteries, this is just us taking a ride on the car with two Mickey ears, okay, they are the GPS signals. We had 2 GPS signals. Even so, the 2 GPS gave us an error of 2 meters, okay? And the fun part is the autonomous driving. As you can see here, I know that is a mess, okay? Because it's made by students. No, I'm joking, of course. No, it's a mess inside the car because we take off, we don't have the wheel right now, okay? We take everything off. Everything that is not necessary, we take it off. We have a computer that is controlling the motor, the traction motor, and the steering wheel. And this is the test. We were pretty sure that it would work, so no one is inside the car. We have an emergency button inside the car. That's why we have 2 guys walking inside the car for them to jump inside the car and push the emergency button. Okay, and the idea was to not hit the guys that are on the chairs. Okay, very slowly, of course, because we don't want to kill anyone. They are not touching the cars, okay? They are just for precaution. It was the first successful autonomous test that we did. Okay? Autonomous in a very, very slow pace. We had to close part of the university during a weekend to do the tests. Okay? This is a parking lot we closed during that weekend. Okay, no one enters. This is dangerous missions now. Okay? And the last thing that I want to show is the people that went through this project. These are all students. Okay, of course, we professors manage all the teams and try to put everyone working together as best as possible. We have people from, for instance, Turkey, from Turkey, okay? She was from Turkey, Mehmet was from Turkey. We had Nicola from Italy, right, Italy. Sebastian, Italy from, no? Germany, Maxine, French, okay? And of course, a lot of Portuguese guys. Okay? So, this is the presentation. The idea here was to try to convince you that you need to work with other engineers from other areas, and you will work, for sure, if you go to the company. Okay, you have questions? Go ahead.
You have said that you're going to implement some cameras in the car.
Yep.
Have you thought about implementing also some
LiDAR.
machine learning
Okay. At this moment, not now, because we have the professors from the decision and control department waiting for us. They are waiting for us too, because we changed the batteries, we changed the battery management system and the motor and the inverters. We did a renew of the car. We are finishing now that. After that, yes, you can do, I think Professor Paulo is an expert on the machine learning. I'm not, okay? I don't know if you want to say some words about this.
We have another project in the university that they are starting to do the processing, image processing. It's not in this vehicle, but it is in that vehicle that is very low and local energy consumption. Yeah. And we are trying to have a student to pick the image and see the lines, not only the straight lines, but also when you do the curve. This is okay. These are very complicated algorithms, and you have to do that. Okay.
Do you have a Formula student here?
yes.
No?
No, we have this kind of
Little car? Not Formula student? Okay. Okay. Yeah, okay. So now Formula student is going to the electric. They are changing from internal combustion cars to electric and autonomous. And they had a camera in the bottom of the car facing the floor, because they want to accelerate as fast as possible without the wheels to spin. So they have the camera to try to know what is the speed related to the ground. They don't want to like start at maximum torque and the car stays in the same place. So there is a world of possibilities on that. Okay. I don't know if you have more questions. Yeah. So before the internal combustion and electric. I cannot say, in our case, we lost weight because we have a very short package of batteries. Our batteries is just for test, 1 hour maximum. So the car should have a range of 20 kilometers or something like that. Okay, so the batteries are, let's say, I can lift them, so it's like 20 kilos. The motor should be 10 kilos, and compare that with a weight of internal combustion engine. So it's almost the same. But in the typical electric cars, we can have weights up to 500 kilos. Yeah. Yeah, the composites too, because you know for sure that you have a big weight of batteries, we need to remove the excess weight. And no, I don't know if someone tells you this, but the batteries last 8 years maximum. So if you buy an electric car right now, prepare to do an investment until next 8 years, and the investment is not low. Okay, for today, I think half of the price of electric cars is the batteries. Sometimes you can rent the batteries instead of buying, yeah.
There is a problem with the guarantee that they do with you. The batteries are packages, of course. If one package goes out, you have to pay one. So they are gaining money renting the batteries, and the batteries will not survive 80 years. They will survive depending on your drive. Okay, so the batteries will be 1 or 2 years, because the capacity will decrease. So careful, guys. Don't trust the marketing. I prefer the hybrid car. Why? What I have seen is, for example, taxis. Taxis, they go to the city and go away, stop, run away, stop, run away, stop, run away. So they can use electric machines when it's driving in the city, okay, and use the combustion when you have a highway. This is me. This is me. What I can do. This is me. But the hybrid car, for me, it is the best one. And it has to be selected according to the function of your car. Because electrical cars will think about Tesla and so on and so on. But you have taxis, you have small trucks that you see in the city, putting the things to the restaurant and so on. So they are usually, there is a huge market there, including the mail post. For example, we know a company in UK, it is called Arrival. It is one of that. They gained UPS 10,000 small trucks because the market, it is not the car that you want to buy, a Tesla. Okay? Don't trust this, my friend. Don't trust this. Don't trust. I'm sorry if there is some person here. But I would like to see trains, small cars. I have seen in Lyon, in France, all taxis are hybrid. They are not double, guys. The Canadian people are also doing this. And you manage where the taxi is going because you know where the streets have a lot of cars or have a lot of, and you have, they have these. So the management is selecting the vehicle that you use, the streets or in the weekend, or it's 1 hour for here, for the place. That's all. Only one thing. This vehicle came from Fiat. They gave us €1. Yes, by €1. And this was produced in 1998. And this was the first total electrical car in Europe. They used this machine, and they used the lead-acid batteries, 15 lead-acid batteries. And they also had the thing to charge the batteries, as you see today. So it was a surprise for me. In 1998, when you were 1 year, with poo-poo like that, you see? So it was. Today I have seen that you have a lot of people in Europe and United States, they collect and they have these cars, like a classical car or something like that. It was very good, very good. Sorry. Stop now, if not we do not lunch.
¿Alguna pregunta más? Ya se han pasado los 30 minutos. Bueno, pues...
I have a question about the autonomy of the car. The car will be totally... the car will be totally autonomous, or you can choose if you can drive it?
Yeah, we have two options. It's the local command, just the pedals and the steering wheel, or you can switch it to remote. Okay. Yeah, and the inverter. The thing is, from the electric point of view of a motor, it's completely different because when we are driving a car, we are pushing the accelerator. It's the torque. So we are not controlling the speed. We are controlling the torque, right? If you're going forward with a certain speed, if you catch a climb, you will slow down. So we are not setting the speed, we are setting the torque. This is the local command. If we drive electric car and if you are controlling the speed with your foot, it will be very strange for the driver. So Local command with the driver, we are controlling the torque. Autonomous, we are controlling the speed. So there are two different ways to control the electric motor, and we have that.
But you can, while you are driving, you can choose the autonomous conduction, but by a safety way. Because I think that it's totally different to adapt all the computer to have the same speed that you had while you were driving.
From an electric point of view, no. We have a switch. We have a small switch. Then if it's up, it's local. If we turn it down, it goes local. It memorizes the speed that you have and keeps the speed. Okay.
And let me only 5 minutes, okay? Why I'm not believing autonomous car. You also have today autonomous vehicles. The airplanes can go do the trip autonomous, my friend. But you will not enter in a train or a car or an airplane without any man, okay, man or woman, man in the subject, because we believe in people, okay? So you today have autonomous. What I believe is the following. The autonomous, semi-autonomous, for example, for the cars that are driving by guys like me, old people. Old people needs care in the rain or in the night. Okay, there is a niche of the market. So you have the guy or girl, old guy or old girl driving, but the system can help, you know, even us. The autonomous car, my friend, it is very beautiful when you have a very large street, like the Americans and in the announcements, very large street without cars, okay? And imagine Valencia, for example, without cars. So you see the publicity. One time I talked with an Audi guy, it was a guy from the Audi. And he showed us a video with a very 8 car. 8 car, it is the car of the Audi. It is a beautiful city. The streets were large, and I was with my students like you, from the electrical drives, and I'm sorry, but which world you are living? Because the normal streets are full of cars. You don't have time to have, or security to have autonomous cars. I do not believe in only an autonomous cars. You have an autonomous cars if you want. The trains can, in general, I like that. So I believe that you have to mixture to help people. For example, to help people in the ambulances. Ambulances? Yeah? Ambulances, for example, they need to go rapid, very fast. And sometimes you don't have the training or the like a formula guy like that. So the system can help because the system can see very fast, you see. So this is a hint for you again, guys. Do these small things. A small car, for example, for the old people, they need that. Okay? They need. It is a niche of market. Imagine, the old people has retired, have money, okay, and they can take advantage of the vehicle, something like that. This is my opinion, my friend. I'm not the normal opinion, but I believe that this is the right way, and not sell dreams, okay, but only for the rich people, sorry.
One question. What is your reflection about the autonomous vehicles in the logistics system, for example, in big trucking, on the big highways, where there's, like, the highways is the safest way to drive, right? What is your opinion on that? Because excuse me, because like Tesla is like developing autonomous trucking right now, and what they say is that it's going to be their most successful product. ever because they're going to employ it in the logistics system.
Very good. Your English is marvelous. We have seen this in Germany because they have the streets or the highways, and the highways are so large that they guard one part of the streets where they put the trucks. Okay. This is a very good idea because you are constructing a train but without connection between them. But one problem is that you have to adapt or construct new highways. So let's see, why not use trains, because you have a lot of lines, and why not adapt the trucks to walk during the railway? Why not? You can only change the movement of the tires.
About that planning, the professors that we have here, let me go back to where's the team? So this one, the middle ones, these are the decision and control. And they have two layers. The planning, where you say, like you go to GPS, you say, I want to go from here to here, they do the planning and so on. But then they have the control at the real time. It's not my expertise area, but these professors are using MPC. Did you already heard about MPC? MPC is some kind of control that predicts what you are doing and then selects the best steering and speed to do some objective function. For instance, save energy, go fast, don't kill anyone. This is a big problem because you have to say in the mathematical point of view what is best. If you are going to have a crash, who are you going to save? The people inside or the other ones? So, it's a crazy world. But for instance, MPC, it's important because if you're going very fast and you find a turn, you know that you have to slow down. And the MPC does something like that. You say, okay, I have a turn in some meters, so I have to slow down because when I turn, I don't want to roll over. Okay, so in the system, in control system, you have the planning that could be done like 1 kilometer by 1 kilometer. In 1 kilometer, you have like a map, and then you have the short term, where in 200 and 200 milliseconds or 100 by 100 milliseconds, you do decisions. Okay, based on the predictions where you think your car is going. Okay, so it's a very complex system, and of course, the big problem here is the sensors. Because you have always some uncertainty, you don't know exactly where you are, and you don't know what is around you. Okay, so it's something that a lot of people, like Tesla, is betting. I think it's good for the science. We will see if we'll get an autonomous world in the future. We'll see, I don't know. It's a very good question. Sensor quality and planning. And of course, if it's a world with only electric cars, it's good because you can communicate with the other cars and say, I'm here where you are, I'm seeing you, but please tell me where you are. So we can do like this, okay? If everyone is autonomous, maybe you have a good solution. You have a safer world. But if just one guy is not autonomous, he could be driving and do something like this. Okay.
No, número de eso. No, no.
Gracias a Paulo y a João y Paulo, por venir, y gracias a vosotros por venir. Y sobre todo, algunos de vosotros estáis en generación espontánea y participáis y sabéis que la conexión con otros grados, y a los que no les...
They are working free, but we have a good team to play football and also to give a lot of them work, doing lunch, so on.
Y el objetivo era que vierais que hay conexiones que ligadas a la mecánica pues dependen de la ingeniería eléctrica y por lo tanto, pues que ya lo sabíais, pero que veis hecho realidad que muchas de las cosas que os ha enseñado Paulo en los vídeos, pues lo tienen ellos hechos en los laboratorios con estudiantes de trabajo final, lo que aquí son trabajos finales de grado y trabajos finales de máster, en su laboratorio pues las diferentes máquinas y el coche pues lo desmontaron y lo montaron ellos convirtiéndolo en eléctrico. Y nada, muchas gracias y imagino que esta tarde y mañana todavía los veréis y a lo mejor a João esta noche todavía sale.